Yes. Only 4 students today? Maybe there are more coming?
Maybe. Or maybe online.
No, online only one I have.
Only one?
Are there more students outside? No, there's one. Only these students? No one else come? No, there's one. Manal, can you hear me?
Yes, miss.
So good evening, everyone. So today we are going to start our second lab, which is lab 2. Okay, here in this lab we will do some basic communication signals. Okay, do you have an idea what are the basic communication signals? Like unit step,
Yes.
delta. These are the basic signals, and these are the basic signals in communication system. Okay, direct means delta function. So it is denoted by delta of t, right? And unit step, and then delta is 1 equals at 0. You know? Okay, this is delta of t. Okay, and then unit step. This is denoted by u of t, right? You know that. And then how is the signal of unit step?
Like this.
Yeah, it goes from 0 to infinity, right? So like this, 0 up to infinity. This is u of t, right? And how about rectangular function?
From 1 to 1.
Yes, yes. According to the preference of user. 1 to 1 or 2 to
2 to 2.
yeah, 1 to 2, anything. Okay. And sine wave. How is sine wave?
From 0.
0 like this.
Yes.
How about the sine?
The sign starts from 1.
90 and like this. This one follow. This is cosine. Starts from 90. Sine of theta or cosine of theta. Okay. I don't have a laser. Okay. So now, if you put zeros in the command window, you know the command window in MATLAB? Command window in MATLAB? Open MATLAB in your devices. Open MATLAB. It's up to you if you want online. It's better. But then you don't have to save your. After I think every 2 months the password expires. It works? Okay, so this is command window in MATLAB. Okay, so what if write zeros? Please pay attention, zeros. For example, if I write 2 and then 3, what does it mean? Can you see it?
No.
I don't know how to make it bigger. Anyway, I tell you here. This you can see, zeros, 1, 3. If you write this in command window, then it means that so it means that 1 row and 3 columns. So you see, this is 1 row and 3 columns. 1, 2, and 3. 3 columns, 1 row. Okay, and all zeros. Okay, you can check this. Try in command window. Just write zeros, 1, 3. They are very useful because we will be using them. Then just try it. Did you try? Try zeros and 1, 3.
Yes.
It is like this. Yes. And then if you write 1, 1, 4, it means that 1 row and 4 columns. This will be 1. Okay. And then if you write some amplitude with it, then all those will be multiplied with 10, and then this will be that constant number you will multiply, then 1 row and then 4 columns will come here. Okay.
You will try all of this.
No, it's just for you. Okay. So sorry, Manar, are you following me? Manar?
Yes, miss.
Okay. So try with me. Okay. So the first
Okay.
returns the matrix of vector 0. The second command returns a matrix of vector 1. And third, a constant number. Now this, what is this? I just told you this. Delta function, yes, it's one impulse at 0. Okay. So we will plot this function in MATLAB. So you all know that if any function is multiplied with delta function, then that function is shift to that impulse. And that function shift to that position of the impulse. Okay, this is the mathematical, this is the graphical representation of this function. Okay, so then, okay, now let's write this program. So if you go to the Moodle, here, so here in the lab work, download this lab 2 examples. So we will do our work here. Okay, download this. You got.
Just
Yeah, that's fine, no problem.
I
But
will
download
it's
this.
okay.
Download this. Go to Moodle. Website. ACSP Moodle. Yes. So you will get this kind of window. Download this from Moodle. It's here. Yes. Why? Put one capital and then star and then numbers and mix it.
After that, one data.
Yes, load value. You're using method here. Yes. You can open. Yeah. Works now. Okay. So all of you, have you downloaded this file and opened it? So let's start, because I will not be making this coding with you because you cannot see my screen. So, and I cannot make it bigger also. So I will be telling you from here. So now for example, if I give you this figure and then I ask you to plot this, first step is to define the scale. Okay. So for this segment, it's my choice from where I want this plot scale. Okay. So from -5 to 5. This is the discrete signal. So there will be no increment. So automatically this MATLAB will take the increment of 1. Okay, then d is equal to 1 for n equal to 0. It means that d, for example, any function, it should be 1 and dot multiply for n is equal to 0. For n is equal to 0. It means that put the value at 0 equals to 1. Put the amplitude at 0 equals to 1. So it will take automatically all the other values 0. Only this amplitude at 0 should be 1. Then you don't have to write this. And then stamp n and d. N is my scale and d is this signal I define. Okay. And then these are the title, label, and x and y label. I told you how to do that in the previous. Okay. Try this function. It works, no? So Manar, also do with me because I will check your work.
Okay, Miss.
Change the change the one.
Mistake. Now, yes.
Sorry. data set will be on the zero.
It is now also on 0, and then amplitude varies.
That is the point.
Yeah, not varies, but it varies to infinity. So it's up to you where you want to stop.
Oh, where you want to stop.
Yeah. So here in the actual example it was one. Then this goes under here. When he changed it to 5, you can change. Also you can change this value to 4. Now you see impulses are 4. Some more examples. Yeah, I think this one but this, you write code here, you write code here and you get it. You know, you don't have to go figure. But I can one. Now right. Yeah. But this is the and so I give you a small activity. So you plotted this at 0. I want you to plot a signal. I want you to plot a signal, delta signal, with amplitude 3 at 5. Plot this one. Because if you understand this, you can plot this very easily. So I will not tell you the code. Plot this impulse at 5 with amplitude of 3. I think you can do it. So here we plotted one amplitude at 0. You have to plot 3 amplitude at 5. How you will change this? Yeah, you will change this. How? No. You want at 5 amplitude 3. Here you did amplitude 1 at 0. Here I want amplitude 3 at 5. 3? 3?
Yeah.
Yeah, when 1 will change to 3, yes, and then 0 will change to 5. Yes. Understand?
Yes.
So this way you can analyze the thing. Show me.
I should ask.
You did it? Yes.
Yeah, that's fine.
And then you can change this if you want to be clear.
Yeah.
But it's not
Yeah, I know.
No, I don't want mine. It's mine when it's not mine. See, the signal shifted to 5. Yeah, and then you increase the scale. And one more thing, if because we are plotting this signal at 5 exactly, and our scale was 5. So if you change this scale to 10 or some higher value than 5, then you will see clearly that you will have an impulse at 5. Just change this scale from -5 to maybe 10 or 8, then you will see this more clearly. Okay. Done?
Yes.
Then some values higher than done. So now,
Brackets you need.
which one?
This brackets we don't know.
No, this is for your understanding, but you need it for your assessment. You have to solve the assessment after that. So you need this file because you will take the reference from here. Okay. So all of you keep this file saved with you because it will help you to solve your assessment. Okay. So now, what is there any problem here? You are talking to that. Okay. Do you understand? So you are talking about. So now this is unit step function. You guys are familiar with it? Yes. So this is u of t. This is 1 for all the values which are greater than or equals to 0. Okay, and then this is 0. At 0, this amplitude is 1. And then for the negative values, it's 0, right? So now what? How I got this function? If I minus u of t minus 1 from u of t, I get this function. See, this is u of t, right? At 0. How can I write this function? How can I get this? Yes. And then from where my function will start? From 1. T equals to 1. This function starts from 0. This starts from 1. If I minus this function from there, what I will get? This will cancel from all other values, and then at 1 I will get this. So my answer will be from 0 to 1, right? Yes. So from 0 to 1 it will be 1. This function. From you see 0 to 1 it is 1, and then it is 0 otherwise, right? So now we will plot unit step function in continuous domain. So we will because we are plotting a continuous function, we need this increment 0.01. Okay. In the previous class, I told you what is this increment. Okay. Then u equals to 0. For what values? U is equal to 0 for all the values which are less than 0. For t values less than 0, my function u of t is 0. Right? For this. And then plus it is 1 dot multiply for all the values of 3 greater than, and also at 0 it's 1 equals to 0. Right? So this is my function here. Did you understand this command? Right? It means that my function is 0 for all the values which are less than 0. Right? And my function is 1 for all the values which are greater than 1, and also at 0 it's 1. So equal to 1. Okay? Equal to 0. At 0 also it's 1, and all the values greater than 0 is 1. You got it? This command means, you see, 0. My function is 0. So it means, you see, unit step is 0 for all the values less than 0, right? 0 for all the values less than 0. This I wrote. Then it's 1 for all the values which are equal to 0 and greater than 0. So 1, this is dot. Okay? For all the values which are greater than 0 and also equal to 0. you understand this command? Because this is the main command you will use it. Then same plot T with respect to U and then put the time. Write it. Manar, are you doing it? Manar,
Yes, miss.
and show me your screen.
Wait, miss. The lab 2 miss ما بطل عندي. خارج دقيقة.
Sorry.
Wait.
Are you downloading now? Are you
I can't
downloading?
download it.
Why? What happened?
I don't know.
Download this and then open in MATLAB.
I can't download it.
Actually, I can't see your. Okay. What does it mean? No? Go up, go up. No, no, no. Just go on the Moodle. You are. Go to 341 lab work. Yeah, this is 341 lab work. Down, down, down. Yes, no, this one. Yes. Go here inside. What happened? I think you don't have MATLAB in your laptop, right?
Yes,
don't have
miss.
So, do you have online?
I open it online, but it's not download in it.
Open online. Open your MATLAB online account.
Okay.
Okay. Open online MATLAB account. Yeah. Okay. But yeah. Yes. Yes. All of you, have you done it? Now let's move to the other one. Sorry. Done? Label? Okay. Manar, what happened? What happened in the online? Yes, Manar. Are you here? You can download it, and also you can try to open it on online version. You can start online also, MATLAB online. Okay. Done. So now we will plot the same unit step function in discrete. So you know that how we can plot the discrete graph, how we can do the discrete graph. Just change the plot, this command plot, change it to stem. With stem you will get the discrete plot, yes? Okay. So you will just change the scale from T to N, and even if you don't change from T to N, just put this on the command to stem instead of plot. Just change it to stem, and then it will give you this plot. Okay. Yes, the first one will change to this one. Stem P comma U. Yes. Same, and then only instead of plot, change stem. Third, yeah. Let me see if it is third. Yeah, I think it's same. Let me check. No, third is other rectangular. So here, just put percent and discrete, and then just change the command. Just write stem T, comma, U. Just write this.
Excuse me?
Yes, just write stem.
I like them. Shows like this.
This one, yeah. Yeah. Because yeah, yeah. Just change this. Remove the anything. Remove it. And then why is this like this? So let's move to other. So we are done with this, and now we will plot the rectangular function. Okay, so how we can plot the rectangular function? So you should tell me how we can plot this figure. Okay, so you see this is 0 for all the values which are less than minus 3. Okay, less than minus 3, and then this is 0 for all the values which are greater than 3. How I can write this? 0, yes, 0, 0 dot multiply, yes, t, yes,
Less than.
less than minus 3, right, then no, and add will be, and I want this, and I want 0 for which value? This and this. So and p greater than 3. Now this also I have. Now I want these two. Yes, I want this also. Now
Plus.
yes, 1 plus 1 for t greater than minus 3. Also at 3 also it's equal also. Yes, minus, yes, and t greater than or equal 3. Yes,
Dot and multiply after 1.
yeah, dot and plus, yes, dot and multiply, yeah, I forgot. Okay, so this easy. Now you can plot any this kind of function, right? So this is, we just have to see, okay, where it is 0, where it is 1. So like this we can write. Okay. So this is a rectangular function. So this means that this is 1 for the values from -1/2 to 1/2. This is this value. So this is from -3. So this is a rectangle. Okay. So how we can write for this? The same, but instead of -3, it will be -1. Yes. 0.5 or -1/2. So instead of 3, this will change to this method. Okay. So I will not show you the code. Just try to write this code for me. Then we will see the code later. But we are writing. So try to write the code for this. Example number 3. So example number 3, write the code yourself. Define the scale. Define the scale. Okay. So define, first of all, what you have to do is define the scale. What is scale? It's up to you. And also put the labels. Define the scale. Write the scale. Okay, write the scale code. Write the scale also. You did that? No. I had space. Okay, I can tell you there. So, do you have idea that how can you write this? Yes. I want you to write it. So, what is the first step? If you see this example, first we define the scale. This scale. First we define the scale. Okay, for any function. Then we store this all result in some variable so that we plot. So do this second step and then this is only 3 lines code. Because that figure was continuous. Right? Define the scale, write the function, and then plot. This is continuous. Did you do that?
No problem.
No. You can put -3, you can make it 5. And for half, this is 3 So should I go forward? So this is the function which we wrote in the previous. Okay, so I want to check with Manar, I think she left. Okay. So this is the function for rectangular this figure. Okay, we wrote the same. So any problem with this? Should I move forward?
Yes.
Now the same can be plotted in STEM, in discrete domain also. Just you have to change it to STEM and then see if you get this. Just and then also from the scale, remove the increment. Okay. Yes. Sorry. Step size of 1. So you see minus 2.5 before there is not step size of 1. If you take step size of 1, it just gives you 1. So you have to put 1 over 2. More. 0.5 is 0.5. Step size of 1 is 8. Right? Change on 4 or 3, but some value bigger than 1 because it takes increment of 1. So it takes all the exponents 1. So increment is 1. Done? All of you? Done? All of you? So, what is that? There is no right. From where you got that? So let's go forward now. Now you know that what is a sine function, sinusoidal function. So for example, if I have this kind of function, periodic, okay, it's oscillating, it's continuous, okay, and then what is this? Yeah, peak to peak, yes, in electronics, but this is signal. So this is amplitude, yes, and then this is frequency, right? This signal has very less frequency, and if I plot another signal like this has high frequency, yes. So any signal is defined by its amplitude and frequency, okay? So we write A sine of omega naught of t. Omega naught is equal to 2 pi f, okay? This A is amplitude. Any sinusoidal function is defined by its amplitude and frequency, okay? Now we can try to plot a sinusoidal function with some frequency. So we will plot this figure. How we will plot it? First, what we need for this function? For this sinusoid, what we need? We need its amplitude. So we see that it's almost equals to 2 minus 2, 2, right? The amplitude is 2. Then it has some frequency, okay? So we define that frequency as 10 hertz, okay? Then this is continuous signal. So we put the increment, and then this sinusoidal waveform oscillates between 0 and 1, okay? Then omega naught is equal to 2 pi into fundamental frequency, which is 10. Then I put all of these things in one function, okay? And then I plot this function with respect to the time scale, okay? Any question for this? Is it clear to you all?
Miss, from where do you know the frequency from the figure?
No, I gave it from my side. It's 10 times. And also, here you see, one cycle is completing around almost here. So one waveform is completing in 1 second. So this is 0.1, this is time scale. So time is equal to 1 by n. 1 by 10 is equal to 0.1. So it's here. Here also you can see that frequency is 10. Okay. So
Yes.
yes.
I have put multiply, I put dot here.
What?
I put dot to the multiply.
Which one? No. Here no. You
Here
don't
no.
want. Yeah.
What's the difference?
The difference is that where you had full scale. When you want element to element multiplication, you put dot. But here, no, it's only one number. One number, 2, one number, 5. Pi is equal to 3.14, right? 3.14. It's 10. So one number. So if there is vector 1, 2, 3, okay, then I need dot. Why? Then if there is a vector like this, then I need dot because I want this number, for example, 2. I want 2 with multiply with this. I want 2 multiply with this also. I want 2 multiply with this also. Then I put dot. Okay. Somewhere. Here, see. This you see amplitude is -2, and then there, and then frequency from here. Yeah, you see this waveform, one cycle is completing here. You know that one waveform is like this. Here at 2 pi, one cycle completes. So where it is completing? See, one sinusoid is here. I think just write F. Okay, if you are confused with F0, just write F. Remove this 0. Just write F. And then also here, just write F. Yeah, F now it's just a variable. Remove 0. So move on. Time. Yeah. Time is already defined here. I'm defining the that is fine. Value of pi is 3.1. I was explaining it. So he asked some question and then I gave answer for this. So this is not for you. Okay. The value of pi is 3.14. I wrote here. Okay. The value of pi is 3.14. I just wrote the value of 3.5. You have to write pi. So you see, this is the figure, right? We want to plot this figure. Okay. So any sinusoidal function, for example, s is equal to a is defined by magnitude, its measure, sinusoid, and then by the amount of right. Then this is equal to 2 pi n. It means it has some is the amplitude. This amplitude, right? Now I want to plot this kind of periodic waveform in matter, right? So from here I put define the scale. Okay, I define that this waveform should oscillate between 0 and 1. 0 and 1, right? And then I gave fundamental frequency of 10. Also, you can see from here, one waveform completes up till here. You know that.
Yes.
One waveform completes its cycle here. Okay. Okay. So, if you see this window, this is almost coming here. It means at point 1, it's completing one cycle. So, you know that what is time? Time is the inverse of frequency. You know that.
Yes.
So 1 divided by 10, it's 0.1. So it means my frequency value is there. Right? So this is the other question.
Okay.
Okay. So I remove this. Okay.
Okay.
So all of you, you understand this problem? So that it doesn't make confusion for you. Done? You got this waveform? You can say none frequency also again, and then you can try to take something. You can increase the amplitude. You can change this waveform to sine. From sine to sine. This sine will move to sine to this. Sine. You see that it will start from like this. One more thing. So, if you all are done with it, I go forward. Yes. It's easy, right? If I take a quiz from you in the next class, can you do that? Same this kind of. If I take a quiz from you.
Well, Miss, we are not prepared for any questions.
Why?
Too late.
No, not now. In the next class. Because this is very easy. And then I get very good response from you, and I assume you are understanding. Can I take a quiz from you in the next class? There is no participant now in my. Okay, so let's move forward. So you are not prepared for the quiz for the next task. I will ask the same some figure and then. Now I think you are prepared. So now this is the last one. Okay, sampling frequency. So anyone have an idea what is sampling frequency? What is sampling frequency? In signal and system, you might have studied it. No? So, number of samples per unit time. How many samples I get in 1 second? That is sampling frequency. How many samples I get in 1 second? That is sampling frequency. Okay? And then, in order to get the number of samples, we have to divide the sampling frequency with the fundamental frequency. F0 divided by Fs. Okay? Then we will get the number of samples. Okay? So you know that omega naught is equal to 2 pi f. Then this will be divided by Fs. Okay? Same thing, but we will only introduce sampling frequency. So this is an example. Find and plot the discretized version of a sine wave at a sampling frequency equal to 500 Hz. Okay, so Fx is equal to 500, and then fundamental frequency F0 is equal to 10. Now the amplitude is 2, same, A is equal to 2, and number of samples required is equal to n is equal to 666. So, if you see this, so number of samples is equal to 60. Then the scale is from 0 to n minus 1. Means scale is from 0 to 59, right? N is 60. Okay. Then fundamental frequency is 10. Fs sampling frequency is 500. A is equal to 2. Same. Just this thing will change here. This will be F0 divided by Fs. 2 pi F0. Okay?
Right?
Yes, I think. The last one.
The last one we write in the example.
Yeah, I think so. I can see.
No, the last.
Yeah. Example 4.
The last one.
This one. Okay. Put the person after that code and write this. Because this is, for example, number 4. Put person. Remove that. Okay. Yeah. I will do that. Yeah. No need to do that. Yes. We'll do it again. Yeah. Why you are speaking? You have a problem? Mira. So, okay. Yes. One. Okay. Okay. No. Okay, yes. I want to tell you the assessment. So, if you are done with this, one more, one last, and then also I have to take your attendance. So, after this, STEM, and then N with respect to Y. Then you will plot it. So, I move forward. Okay, done? Yeah, I plot it. You wrote this and then write this at the end. Yes. No, that's fine. What have you done it? So all of you have done it. Now I tell you how to solve your assessment. No, no, it's stuck now. So this was the last. Now just you will put this stem, and you already did that. Okay. This is with fundamental frequency of 10 hertz. Okay. This was with 500, and then this is for with 10. You can change it, and you will get this figure also. But we are not going to do it now because we are almost running out of time. So I show you how. Now this is your assessment. Okay. I will put it on Moodle. So this is your. This time I want PDF from you. I will put MLX file. You have to export it to PDF and submit. Because it's difficult for me to download MLX file and see for all of you. So I want you this time to submit PDF with comments and everything. Okay. So we have this function g of t is equal to g naught sine of omega naught t. It's the same. G naught is the. I can't write. So G naught is the amplitude, right? Yes. Let's see if I can draw it. Okay, I can. So
First one.
what? So G naught is the amplitude, right? And then sine is sinusoidal function, omega naught is equal to 2 pi f, you know. So you just have to plot the amplitude of sine wave is 5. So this G naught is equal to 5, right? And then fundamental frequency is equal to 20. This is F naught. Okay, it's not possible. F naught is equal to 20, right? Then number of samples n is equal to capital N is equal to 45. Show the result in threads. The plots should be red color. You know how to do that. Add the title to the graph and a suitable label for x and y axis. Okay, note the color for the code is red. Then you have to write code for this figure. Okay, this figure is starting from -4 up till 4. Amplitude is 3. Okay, write the code for this figure. Okay. Sorry. Yeah, that's it. Yes, we did it today.
Yes.
So then write a code for this figure also. You can do it. This is again rectangular but stem is green, right? This starts from -5 until 3. Okay, amplitude is 4. Okay, done.
Okay.
You can do it. Then also we plot this function, you should see that this
-1.
it's -3. Yes, who said minus? You said yes. -3. It is not going until -infinity. So you have to see the limit. And then here it's 9. 9. Okay, you have to plot this also. So you can do it, right? We did it today. If you start to do it tonight, then you will have your fresh mind and you will have your fresh knowledge. You can do it. And then just submit it on. Okay? I will generate the link now. Okay, just these. Okay. Only 4%. 3 figures. And then I want the submission from you in PDF. Okay. So I want all of you to come here to write your student ID so that I can put your attendance. So this is section, which one? 2. Section 2, 341. Just write your student ID.
Last day is submission. Which day?
3 days from now.
Just
I think 2 days is okay.
No.
1 week.
Yes.
1 week is because I have to check everything. I do everything in front of you. Even you can do it in 5 minutes now. Very easy.
1 week is good. We used to
1 week is
have
not
1
good.
week.
No. If 1 week is good, I will add more questions. Yes. Okay, and very complicated questions, right? If you want 1 week, then 2 more questions. Yes. Come and write your student ID. Please come for your attendance. Sunday. Yeah. Right? What do you write?
Thank you.
It will be Saturday. Saturday at midnight. Midnight. Yes. It's easy. Okay. Saturday midnight will be the deadline. Okay. Come for your attendance. Okay.
وين انت هذا شو تسجلين وين انت؟ يعني اخواني معاكم سجل اسمي معاكم بمادة مالت مرض هي 420 يا حياتي بطلت هيدفع رحت من واحد يبي بديك على ابوي ها بديك على ابوي ايه ديك يلا يلا سجلت شو يلا
also
Yes,
do your attendance? Yeah. Tell me your student ID so that I can write your attendance. Student 04. And did you do that attendance? Uh-huh. Yes. Okay. Sorry.
181030.
Okay. Okay. This is section 2. Yeah, now I am doing it. Yes, 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 yes. So submit. Okay. Yeah, okay. You see this submission link is here now. This one. Okay. And okay, one more thing. I will put this also. Okay. Done? No problem.